Today we are going to go over 8.5 alternating series. Alternating series is a series that contains both positive and negative terms. There are two versions of alternating series. When the odd indexed terms are negative, for example, all the odd ones are negative, all the even ones are positive, or all the odd ones are positive, all the even ones are negative. And the form of the series will look like -1 to some power, -1 to some power times a of n or a of k. Something look like here. So today we are going to go over how do we test the convergence or divergence of alternating series. So for alternating series, the conditions are here. The alternating series test conditions. If you look at here, an, keep in mind, an is a term without -1 to the nth power. We neglect -1 to the n, and whatever is left, we call it an. If an is positive, and the limit of n go to infinity, a of n is 0, equals 0 here. And also, a of n is decreasing. If that means an is greater or equal than an plus 1, if all the three conditions are satisfied, we call the alternating series converges. There are two ways to prove a of n is decreasing. One is by doing subtraction, an plus 1 minus an less than 0, or sometimes, especially if we have power function or exponential function, we can use the ratio less than 1. So if all the three conditions are satisfied, we call the series converges. Otherwise, if limit n go to infinity, a of n is not 0. So based on the nth term test, our conclusion will be the series diverges. Otherwise, no conclusion. So before we apply the alternating series test, we have to make sure it is an alternating series. And what is your an in this case? For example, find the an in the following series. We have to change the form into our standard form. So -3 equals -1 times 3. It's -1 to the n times 3 to the n. So an will be 3 to the nth power. The term without -1 to the n. Similarly, we factor -1 out. So it's -1 to the n plus 1 times 2n minus 1 to the n plus 1. So this part will be our an. And also sometimes we have to identify if the given series is an alternating series. For example, this one, we split into two parts. So yes, it is an alternating series. And also at the same time, this is also a geometric series. So similarly, this one, -1 to the 2n times 3 to the 2n. As we know, to the -1 to the eventh power give us 1. So this series will be equal to this, which is not an alternating series. Similarly, -1 to the 2n plus 1 times 2 to the 2n plus 1. To an odd power will always give us -1. So this is a series with all the terms negative, which is not an alternating series. How do we prove the convergence or divergence of a series? For example, this one. So if you look at this one, this series, we have -1 to the n times 1. So our an in this case is 1. So an positive, limit as n go to infinity, a of n, which is 1, not a 0. So directly our series diverges. Let's look at example here. So this one equals n over -1 to the n minus 1 times 2 to the n minus 1. So -1 to the n minus 1 in the denominator doesn't really matter. We can, any case like this, we can directly bring the n minus 1 to the top. So our an is n over 2 n minus 1. So three conditions: an positive, limit and go to infinity, a of n equals 0. Next, we have to prove it's increasing or decreasing because we have exponential function. I'm going to do an plus 1 over an. So plug n plus 1 in, so it's n plus 1 over 2 to the n over n divided by this. Simplify a little bit. N plus 1 divided by 2n, which is less than 1. So it decreases. So three conditions satisfied, so the series converges. The last three problems, you can do it yourself and compare your answer with mine. Here are my answers for the last three problems.